Alrighty, let's double check my sound is working. We are cooking. Woo! First off, because I have failed to do this in every previous stream, I wanted to introduce myself. So I apologize to everyone for failing to do that in previous streams. So, hello. My name is Miranda Auhl. I am a developer advocate for Timescale, and I'm based in Pennsylvania, actually. So, shout out to all you Pennsylvania folks. Yeah, so I guess if, we would love to hear more from you guys as the viewers. Oh, yes. Hello, 𝗔𝗯𝗃𝗃. So feel free to jump in on the chat and ask questions. We care about engaging with you guys. That's part of why we want to do Twitch streams. So please feel free to ask questions, hop in. If you have a funny, appropriate joke, that's always funny. I love the memes. I'm all about memes. I do enjoy memes. So yeah, feel comfortable. And let's get started. Woo! Sorry, my extra Mac laptop just fell asleep and I use it for some notes for myself. So apologize, just getting that all ready. Okay, so today we are going to be looking at how to animate NFL data using TimescaleDB and Python. Now, if you have been able to join previous streams, you likely have been introduced to the data so many times now. But for people that are new and a refresher, it's been a few weeks. I mean, maybe you have a super memory. I do not. So we're going to kind of recap and then go through how to actually do everything. And I guess that's a good time to show the agenda. Right? Probably should have showed that before. And I'm getting some Slack messages. Let's just make sure I'm rocking and rolling. All right, I think we're good. Tight. Okay, so for the agenda today, we're going to recap the data set. We're going to then create the field in Python to, plot all the players' moves. So we're going to create the field. Then we are going to pull in the data from TimescaleDB. And then we're going to animate it, right? That's probably why most of you are here today, is because animations are bomb. So who doesn't want to animate? And then finally, we'll just wrap it up. So cool beans. Let's get started. Recap on the data set. So to recap on the data set, we are going to actually bump over to, let me just make sure that I have these tables showing. Oh, reconnect. I got disconnected from my database. Okay, let's get reconnected. I think we are rocking and rolling. Okay. Using a lot of rocking and rolling, not sure where that came from. All right, so this is 𝗙𝗵𝗽. If you are not familiar with it, it's a great tool, visualization tool for working with data. I will probably use it in every stream, so just wanted to give a recap in case you're seeing this and is like, whew, this is awesome. I want to use this. You can use that. 𝗙𝗵𝗽, it's free too, which is cool. Okay, so recap on the data. We have the NFL provided a bunch of data because they essentially did this big data bowl, it was the 2021 big data bowl, and the point of it was to have people kind of analyze or figure out, use machine learning and AI to see if they could predict plays or like categorize them, you know, whatever, like just work with play data, passing play data. So NFL provided a ton of data to allow, you know, data scientists or amateurs or whoever to play around with it, which is super cool. Thank you, NFL. Because usually if you are familiar with trying to get NFL data, it's like lock and key. You have to pay a bunch of money to get it anyways. So this is free. It's all in Kaggle. If you look up Kaggle Big Data Bowl, you can get access to, I think you have to have a Kaggle account to download the data, but you can play around with it, which is super cool. So anyways, back to the data. So this is the tracking table, and the tracking table, I'm going to show you two tables today, because those are the two tables that we really care about. So tracking, if we look at this here, is a time series. Time series data is everywhere. We have time series data that essentially, this data set is acting like an IoT data set because they put RFID tags on all of the players and the football, which allow us to track. It like every moment, like practically every moment of each game in the 2018 season for NFL, which is amazing. That's crazy. Like, it uses X and Y coordinates to do this. And it's, so every fourth of a second, which if you look at the data, seems like I'm pulling that out of nowhere. But again, this is why data analysis, you got to get to know the data. But every quarter second practically, they're getting X and Y coordinates on the field as a plane for where each player is and the football is, or players involved in a passing play. Anyways, like on a coordinate plane of the field, which is crazy, right? That's super cool. And it also includes like speed, acceleration, distance traveled, all this awesome stuff. Primarily, right, since today we're looking at animating players' movements, the most important thing that we want to know is, right, their location at each given second, which we are given, which is awesome. And then, right, we're also interested in an individual play. And so I'm actually going to scoot on over to this frame ID column, which we're going to be looking at a lot today and utilizing. Because this frame ID essentially breaks up each play into that, like, categorizing each moment that readings were taken. So, right, this is like a bunch of players. So, like, for each player, right, they're getting a reading for frame ID 1. And then each player is going to get another reading for frame ID 2, right? So this frame ID can be it can be matched or mapped to an individual play ID, I should say. So we're going to be using that and the coordinate system to really kind of animate this. So just recap on the data, tracking data, IoT data set. And since we do only have passing plays identified, I'll open the play table real quick. Since we only have passing plays identified, we're going to be animating passing plays, like a passing play today, and probably, you might be able to manipulate the data a little bit to get other plays. Because, right, they're taking the measurements. They're theoretically, right, you could plot an entire game, on the field if you wanted. You can extrapolate this as far as you want to go. You do you. But yeah, so that's kind of getting to know the data. We're recapping on everything. Great. Now, let's get to the fun stuff. Let's create the field. So I'm going to hop on over to VS Code So VS Code is another fantastic tool. If you if you are not familiar with it, check it out. It's awesome. I prefer VS Code to Visual Studio. That's a whole nother debate, but personally I'm a VS Code gal, so I think it's better. But I'm not gonna start battles here today. So okay, so I'm gonna be using VS Code, and I'm actually using a Jupyter notebook, just to kind of like allow us to kind of walk through the Python code together and kind of see how it's coming together. So yeah, that's what I'm using for this first kind of script. And then actually for animation, it's very hard to do the animation within Jupyter Notebook. So then I'll actually pop over to just a Python script that includes all of the code that we'll go over in the Jupyter Notebook. So just to give you some backstory. So first thing with Python, right? I need to import all the needed modules in Python. I'm assuming that most everyone here is somewhat familiar with Python. But so importing your modules to actually use these libraries and like use the functions that they allow, you have to import them. So I gotta import everything. So I'm using config parser because I am not going to show you my database password. And so I'm using this config parser to allow me to use a environment file, all that good stuff. Great for, you should just be using that anyways. So 𝗖𝗵𝗽𝗀 is a module to help us connect to TimescaleDB, and it's a great module for doing so. We're going to use good old pandas because we need to store the data somewhere in Python, and data frames are a great option. NumPy, actually I don't even think I use this, so I could probably delete that, but whatever. Matplotlib, this is where the good stuff is coming from, right? We're getting our all of the visualization capabilities we're taking from the Matplotlib module. Try saying that 5 times fast. I'm not going to try because I suck at that. So, all right. So I use my config parser to get all my database information, and then I'm going to, essentially this code, I'm establishing connection, or I'm creating a connection to the database that I can use then to actually pull data out of the database. So, right, you just need a database, host, user, password, port. Good beans. Good beans? That's a new one. Cool beans. Guess I'm just making things up now. That's normal. Okay, so we have kind of like things set up for us. We're all good. Let's actually create the field. So, and also, side note, I actually did make this repository. It's on my GitHub, and it is public. So you can pull this file and the Jupyter Notebook, and if you have the data stored somewhere, you can create your own environment file and pull in your like config stuff. But if you want to use this code specifically, and if you want to look at all my cool links that I included, links, you can clone the repository and play around with it. So whatever, it's all good. Okay, so let's create the field. So first we're going to create a rectangle. Now I feel like I'm, is that the Charlie Brown? What is that? I don't need to be asking that question right now. Oh yes, my coffee delivery is here. My husband brought me my coffee. Thank you. That's very kind. Because as we've established in previous streams, if you have not joined, in previous streams, then you are now learning this. I love coffee. It is my lifeblood. But tea is underrated. I love tea as well. Anyways, so first we're going to create a rectangle that is green for the field. You know, gotta have some green grass. Next, we're going to kind of create the subplot structure, and then we're going to then add the color to the subplot. So it's kind of also, I don't know if y'all feel this. Oh, yes, just poured some coffee from the French press. Yeah, I do love French press. Also pour-overs. I love pour-overs. That stuff is... I used to actually be a barista, small tangent, and like it was back in college, and gosh, I kid you not, there was one shift I had 6 double shots of espresso and a couple cups of coffee. Let's just say I thought I might have had heart palpitations. Don't drink that much coffee, folks. You will hurt yourself. It's not good. But it's delicious, so, you know, you take some, you leave some. Anyways, so oh, right, I was going to mention that personally, in my own experience with Matplotlib, the module, a lot of understanding how to set up the plots and actually create visualizations is kind of like learning a language, in the sense that it's not super intuitive. And I apologize if there are any Matplotlib like fanatics here and, you know, are thinking like, oh, it's so easy. Yeah, it was not for me. I feel like it's not always super intuitive. So keep in mind that like how I found out a lot about these like how to structure, you know, plot subplots, like right here, like plot subplots, and like knowing how to use Fig and like the axes, like it takes practice. And a lot of it, I'm gonna be honest, is intuition. Once you just use it enough, you kind of have intuition like, oh, I think ax dot add patch. Yeah, so keep in mind that if you are struggling to like create visualizations with Matplotlib, you're not the only one. It's not super intuitive. So just wanted to give that little caveat. So just keep that in mind if you're like, whoa, how did you do this? Like it's you can do it too, is what I'm saying. Anyways, so first, right, we're creating our green rectangle patch. So we're using patches. Again, I have links to all of this if you pull down the repository yourself. And then if you look at the function, like 0, 0 is like the corner point, and then you put in like the X and then the Y coordinates. And so then I did an edge color of black and a like main color of green. And so then here I'm creating the subplot, the figure, and like the figure size so that it gives us dimensions, like very specific dimensions. And then I'm adding the green patch. So let's run this code. Ooh, oh, right. Haha. I didn't actually run the import. That's an important step with using Jupyter notebooks. Haha. So there we go. Huzzah. Why did I use that? Okay. We have our field. Woo! This is awesome. Cool beans. So then next, right, we have our field, but like, what is happening on the field? Do we even know what's going on? Like, how do we know where the field lines are, right? So we need to add, the field lines to our beautiful green field, grassy green field. So in this section, so just also note, this is the same code from above. I'm only just doing that so that we can add on to the plot. That's just another Jupyter notebook thing. So that's why I'm not going to go over this again, but this is like where the plot lines come in. So next, let's plot our field lines, right? Like all that good stuff. The yard lines. Words are not my friend, apparently, ever, but particularly this morning. Okay, so plot lines, right? We want to know the 10, 20, 30, 40, 50, 60, all the way to 110 yard lines. And I'm going to make them white. So this is just kind of setting up an array, which then I apply to this function, which is just exposes the axis line at, this specific point, and I'm going to make it white. So this is like basically created like a quick kind of like looping function, which probably, if you're familiar with Python, right, you've used for a in something, accomplish this function where, like, you're plugging in a for a value. Anyways, usually it's x, but I'm using a for this case because I don't know, I was just feeling like a. I don't know. So this function will actually plot our yard lines. Just gonna take a sip of my coffee. Just get some of my life back. Then I'm actually also going to get the y-axis. So right, all the yards are going on the x-axis, and you can see that, right, because our x-axis is along kind of like lengthwise along the field, and then y is like the width of the field, or like the height, or I guess it depends on how you're looking at it, so that doesn't really help. But this will provide the horizontal lines just to give if you don't do this, the plot will not, for this code, the plot will not understand the y-axis boundaries, and so it just gets real wonky. So that's why I included these. So it just sets us up for making sure our coordinate system is working correctly. And then here, for this function, we're just plotting numbers for our yard lines to just give us context, to know, like, which yard line is which, right? It's useful. So again, this is just a function, we're using a range, then we're like applying text, all that good stuff, horizontal alignment, we're doing it on the center of it. Beautiful. Okay, so if I run this, wow, we got a field. That's a football field, yeah. But, right, still not enough, because, right, it's useful to know, like, the typical hash marks, right, to show kind of like where the center of the field is, and like the boundaries. So we're going to also add our hash marks for the field, like the hash marks for the field, to kind of identify that middle strip and, the boundaries and stuff, all that cool stuff. Because the yard lines are useful, but having extra information is always helpful. So here we are, again, this is code that we have already run in the previous Jupyter Notebook, like, snippets. So ignore this, right? We've already done all this. We're all good. So then for the hash marks, again, we're just using a function, and then we are plotting these hash marks, these lines, and also turning off the axis so that, we, just to make it look more like a field, we can just remove that. Also, I wanted to give a shout out to my colleague Attila, who first wrote a lot of this code, and to just plot a static field. And so shout out to him for all of his amazing work. He does a lot of really cool Python stuff, so definitely check out Attila's work with Timescale. Sorry, I should have mentioned that before. My brain. But yeah, shout out to him. Thank you. Okay, so we run this, and we get our hash lines. Beautiful, beautiful. So now we kind of know center of the field, what's going on. We have a little bit more spatial reasoning. Okay, so then, just looking at some messages, getting some messages rolling in. So to make our lives easier and to actually use this in the animation part, we need to create, or I'm going to create, a function for the field. And this just essentially helps us to utilize the field and then also pulling data, which we're going to do next, just to make the animation easier and more readable. So now I'm going to actually define the function. So this is all the code that we went over, okay? This is all the code. So nothing is new here. I'm just putting it inside of a function and putting out, our figure and axis variables, okay? So that's just, nothing brand new here. And then it just creates a function. So we don't see an output, right? Because we're just creating a function that we can then call and use. So now that we have a field, right? We created this great field. Awesome. But, right, we need to pull in the data and actually plot that on top of our field, right? So this is where we need to connect to our TimescaleDB instance and pull in the needed data. So in order to kind of, again, set this up so that I can use it as a function, I created it so that, it's in kind of inserting given set values into kind of like our select statement. So instead of putting like 2018-111900 in here inside of the string and the hard coding that, I'm making it so we can set this up for a variable function that we can use for any game ID, any play ID, and any frame. So that's why I'm kind of like setting these objects because then I can actually use them as kind of like inserted into my SQL code, which then I will use to get the data from TimescaleDB. So before I hop directly into this, I just want to, so why I chose this game ID, this play ID, and the frame, again, from before when we were getting to know our data again, or recapping on the data, I guess I should say. There's a lot of agains in that statement. It's confusing me. So this is one specific game ID, which is unique, right, to a single game, with one play ID, which is unique to a single play within that game, right? So this is narrowing down a single play within this particular game. And then we're just grabbing kind of like the first frame of information. So in our tracking data, if I hop back over to 𝗔𝗵𝗽𝗍, you can actually, I created a query to specifically look at this game ID and this play ID that we're going to be kind of animating, just to kind of get like a data-based picture. Inference? I don't know. That's probably not the right word that I'm looking for. And just understand what's going on with the data in this scenario. So when I run this query, right, this is for this specific game, for this specific play, and I'm ordering it by time, so I get the most recent to the, and first moment of the play to the last moment of the play. This is the data that we're provided. So this is the data, right, that I want to pull and use for my animation. Now the animating part comes a little bit later, right? Because first we need to kind of just figure out how to plot the information on the field, which is what we're going to be doing right now. But again, if you notice, right, we have our frame IDs. And so we are just looking at, for this first kind of go around to pull in the data and plotting it, we're just looking at this one frame, okay? Only this information, this 15 rows of information. So you can probably start to kind of see like, oh, so we're looking at one frame right now, but when we animate, we can look at all the frames to kind of paint the picture. Anyways, okay. I'm just going on tangents here. Okay, so back to VS Code, just to give you a quick, reminder of what data we're actually pulling in. So first, I want to know who is the home team, right? If I were to just plot all the players' positions in this passing play on the field with no identification of who's home and who's away, that would be confusing, right? I mean, football, like, they might start out in like a specified order where you can identify, oh, that's clearly one team and that's clearly another. But when they start running around, you have no idea. Unless you're like crazy good at like following dots and knowing which ones were started on which side. So we need to identify who is the home team and who is the away team. So here we're going to select all from tracking where game ID is equal to, the specific game that we're looking at, and play ID is equal to the specific play we're looking at, and team, and if we go back to our 𝗔𝗵𝗽𝗏, we see that we do have identification of if a individual is on the home or away team to verify which side we need to, which side they're on, categorize them, right? Perfect. So back to VS Code. So then we're only grabbing home team player movements for that moment. Also, my neighbor, which is probably what you're hearing in the background, is having a tree chopped down. So it's a little loud. I apologize for that. I also meant to mention that. Oops. My bad. Okay. So, and then we're also pulling just one frame of information at this moment. That's so loud. So then I'm just then we're just formatting the data in a specific way. And then we're getting the home team data. We're actually reading the pandas. Sorry, I apologize. My brain is just like, it's fair. I hope it's not this loud for you guys. That's, probably should have asked them to cut down their tree another day. No, I'm just kidding. That would have been really rude. So I'm using pandas which provides the read SQL function. That's a pandas function that you can pull from to essentially read your SQL, and it gives, it has your SQL statement and then your connection string to connect to your database, pull in the data, put it into a data frame, and that's what this, home team, what we kind of get out of it. Then, right, we want to do the same thing for the away team, right? We're going to do the same thing. We're going to pull the data, get the away team information, and then actually we also want to do the same thing for the football because, right, going back to 𝗔𝗵𝗽𝗏, the football is not on a single team, which is good because that would be strange. So the football has its own team identification, so we also want to pull the football information. So this is querying data for the football. Then I'm going to generate my field. So I pulled in the information, and we have our data frames. We pulled in the information. Then I want to plot the field, okay? And then on the field, we're going to plot the players and the football positions. So first we want to plot the field, and then we can plot the home team's positions, which I'm making blue. Then we're going to plot the away team's position, which I'm making red. And then I'm going to plot the football's position, which I'm making yellow, okay? And if the X and Y, right, that's actually the name of, I'm gonna just jumping back and forth here, my bad. But if you remember, right, X and Y refers to literally the X and Y columns, which are the X and Y coordinates for each player or the ball at any one time. So that's why, we're able to just call, right, the data frame's X column information and the data frame's Y column information. Okay. So, and then this is an additional query that's just getting the play description and the possession team, just like as a little note at the top. This is very similar to some of the queries that we looked at in previous streams, just grabbing that info for extra context. So, okay. So if we run this, beautiful. We see, right, we have blue is the home team, red is the away team, yellow is the football. Looks good, right? That's one moment, right? So how do we take this single snapshot and animate it, right? So that's where we make another function. Whee! Functions! Yay! So we're going to create a function where it takes in a game ID value, a play ID value, and a frame. If you remember, that's how we set up our queries, to take in, a game object, a play object, and a frame object, just kind of getting, allowing us to, on the fly, pick whichever game ID, play ID, or frame we wanted, right? So I define this function, and I run my SQL, and so this is all the same code that we just looked at, but I'm just defining a function where I can put, instead of hard coding values into it like here, I can insert it through via the function call, which we made draw play and then game ID, play ID, frame ID. Okay. So now that we have functions for creating the field and generating players' positions on the field, let's animate some things. Whoop, whoop. So let's go back to 𝗔𝗵𝗽𝗏. And so part of animating is, at least using the function animation, is that you want to know how many frames it's going to play over. Right, with the animation, we're essentially taking, instead of just one frame, we're going to plot one frame, then two, then the second frame, third frame, continuously until you, you see these plotted figures start moving, right? So that's kind of how this animation works, is that you're taking static data, which occurs over time, and you're kind of stringing it together into one image. And in this case, I wanted to keep the player's previous positions. So keep in mind that how I'm setting up this animation is actually going to show, if a player went from point A to point B, it would show the line, the dots of, as they kind of ran, as information from their RFID tag was being passed into the database, we're, seeing point. And you can decide to turn that off. You can decide to build your animation functions to not show kind of that stream, the historic movement. But in this case, I wanted to do that because I find that helpful to see, where did they run to get to where they are. Anyways, so just some backstory on that. But what I want you to see is, you can essentially take this static data with these frame IDs and kind of snapshot this, first frame moment, second frame moment, third frame moment until the end of the play. Now, with animation, right, we need to know when the play ends, so, because we're going to input, draw this field with the players on it, from frame 1 to frame X, and, show me how it's being plotted, right? We need to know where it ends, right? We can't just say from frame 1 to infinity, because there is no infinity. So part of your animation is knowing like when you want it to stop taking in and stop taking in certain data from our pulled in data set, because the play only has a specific amount of time that it's running over. So to find the max frame ID to make sure that we're stopping once the play is ended, we're telling the function, okay, when the play ends, we're running this select max frame ID. So we're getting the largest frame ID from tracking, where the game is the game that we have been looking at and the play is the play that we've been looking at. So if I do this, oh, sorry, it's probably did it in a weird spot. So the max is 113. So we have 113 possible frames of information that we could be plotting. Okay, so keep that in mind, 113 frames. So let's go back to VS Code. So, we generate our field first, and then we're going to plot these kind of like animated points on top of the field. So first, in order to do that, if you're using the function animation function, I guess, from, I was trying to think of another word for that, but it's really, function. From matplotlib, it requires a figure to be kind of drawing on. It requires a function, an animation function. And again, I have a link in here for details on the function animation. So you want to make sure to look that up if you are using animation, using this function. You want to know how to use it. So we're taking this update plot animation function, which is what essentially this function animation is going to iterate over. What function is it going to iterate through? The number of frames that you want to iterate over, which that's why we had to get the max frames from our database information, because we need to know, how many frames are we going through? And so it's 113 frames. So it needs to iterate over all of those frames. And then this interval is just a way to, I believe the default is interval equal to 100. It has to do with how fast I think it's the milliseconds between one plotted point to another plotted point in kind of the frame timeline. So this just speeds up your animation essentially. And I felt like 100 was a little bit too slow, was a little bit boring. I feel like animation should be kind of snappy. So that's why I made that 10. And then this is actually just setting figure height and width to a specific amount to make it a little bit bigger and showing the plot. Excuse me. So that's kind of like what this... I wanted to show this first before I jump back to my animation function, just because you have to have that animation function, to show why I created this animation function. So let's go back to the animation function. Essentially, I'm taking that draw play function, okay? I'm iterating over it with I equal to the frame input information, okay? Now, you would have to change this since, in this case, in this data set, I have frames. If you wanted to do it over time, you would just have to adjust kind of like your your queries and this function to, iterate over time instead of frames, which you can totally do. In this case, we can use frames because that's how this data set is set up, which is really nice. It's almost like they wanted you to animate, just, you know, because part of the competition was animating plays, but anyways, just chatting with myself. Ooh, I should actually check if there are any questions. Okay, no, we don't have any questions. Brilliant, brilliant. Okay, so then so we have, for our animation function, we are drawing, you know, plotting one set of information for frame 1, and then how it iterates is that then it will go back and plot for frame 2, for frame 3, 4, continuously onward until you have all the frames from 1 to 113 plotted on your graph. So this is the kind of moment of truth that we've been building up to. Okay, so once again, Jupyter Notebook does not work super well with the animating parts of it, so we're actually going to hop over to this Python script. And again, this is all the data, this is all the same information that we have covered in the Jupyter Notebook. So I'm going to run this. Okay, it's debugging. All right. Oh boy, moment of truth. Okay, we see we got a player down here. Okay, he's got the ball. He's going. Okay, what's going to happen? Oh, he's throwing the football. Okay, we can see the football is being thrown to this player here. Catches it, it appears, is running towards the goal, and I don't think blue can catch him. Oh, he scored one. Oh boy. Wow. Nice. That's good soup. Okay, so sweet. We animated one play, and it will actually keep kind of like, it will keep playing. So you'll see kind of like go over the lines that you already have. But awesome. We now have this play animation. And what's cool is that by setting it up, you know, to have a function to draw the the specific play, I could switch this out for, you know, any other play and show, you know, a different passing play if I wanted. You know, you could pick any play ID. You could pick any game in the season. As long as you know the number of frames that it's over, like, you can animate it, which is really cool. And, you know, you could think of the possibilities, like you could put each, like, the player's name on the field if you wanted. You could have their jersey number. You know, you can just play around with what you're displaying kind of in our plotting function, our draw play function. You know, you can add additional data if you want. It's totally up to you. So this is just kind of like a starting point of how you could animate this NFL play data with Python and TimescaleDB. So that's pretty much it for today. I definitely didn't go back to the PowerPoint for all these lovely slides. Oops, haha. So as a wrap up, I did want to get you guys pumped for some very exciting stuff coming in the pipeline. Oh, a link to the source. Yes, okay, let me pull up Kaggle and get you a link to the source for this data, and actually my GitHub in case you want to pull it yourselves. So let me just get that for you. So Kaggle. Okay. So this is the Kaggle information. And then for my GitHub, Oh. What is on? Right. I was in the wrong browser. The wrong browser. Okay. And NFL animation. And here is my GitHub if you want to pull down this repository and do the animations yourself. So, yeah, you are welcome. Okay. So yeah, a wrap up. I wanted to get you guys excited because there is awesome additional content coming down the line for animating NFL data and just kind of like visually seeing it play out. And that's using TimescaleDB and PostGIS. And Ryan Lambert from Rust-Proof Labs is going to be writing some content and actually doing some streams on how to use PostGIS and these awesome tools to animate, like, I think even more, like far more than you could do with Python. Like, it's crazy cool, the stuff that he demoed for us. I guess it was like a week or two ago. So I'm super excited to learn more about it. But I just wanted to get you guys pumped and excited for that because I think that's going to be super awesome. And if you haven't checked out PostGIS, definitely check it out. Really cool functionality that you can kind of play around with geospatial data and functions and things like that. Anyways, so thank you for coming. That's pretty much it. Yeah, feel free to ask me any questions if you have any later on. And definitely check out TimescaleDB if you have not. Likely you probably have because that's why you're here. But you can join our Slack. We have our community Slack, which is awesome. And I'll be posting a lot of links on the YouTube recording, so you can find a lot of links to our docs and things like that, our Slack community, all that good stuff. So yeah, hope that you all have a fantastic day, and we will see you next time. Unless anyone has any questions. Okay, I think that's a no. We're good.